Now let us see the transfer characteristics of JFET. In the previous class, in the previous lecture we have seen the JFET classification of JFET and drain character working and drain characteristics of JFET. Now today we'll see the transfer characteristics of JFET. That is nothing but VGS versus ID. Since we know that the VGS, the voltage between the gate and the source, if this voltage decreases or from 0, if it decreases from 0, then here VGS, for this value of, for VGS equal to 0, you have ID some value, that value is called IDSS, and for VGS is equal to -1 volt, the level of ID will be further decreased because of the more depletion, more reverse bias voltage, and for VGS equal to 2, still less. Now let us see the Shockley equation, also called square law equation. The transfer characteristics of JFET is given by ID is equal to IDSS into 1 minus VGS by VP whole square. Now let us see the first case. When VGS is equal to 0, substitute 0 here. 1 minus 0 by something will be 0. Therefore 1 minus 0 is 0. Therefore ID is equal to IDSS. Now second case where VGS is equal to VP. So VGS and VP are same, therefore they become 1. 1 minus 1 0. 0 whole square will be 0. Therefore ID will be 0. The input resistance Rn is given by VGS by VGSS. A certain JFET has IGSS as 2 nanoamperes for VGS is equal to minus 20 volts. Determine input resistance. So R is equal to VGS by IGSS. So substitute IGSS and also VGS. We'll get here 10 into 10 raised to 9 ohms. That is nothing but 10. Rn is equal to 10,000 megohms. Now sketch the transfer characteristics of N-channel JFET given IDSS as 12 milliamperes and VPS minus 6 volts. So we know the Shockley, according to the Shockley equation, ID is equal to IDSS into 1 minus VGS by VP whole square. So IDSS is given as 12 volts and VP is given as minus 6 volts. So let us take for the different cases, as we have to sketch the transfer characteristics. Let us take VGS is equal to 0 first. For VGS equal to 0, ID you get is 12 milliamperes. For VGS equal to minus 1 volts, get ID, say in the same formula, ID is equal to 8.33. For VGS equal to minus 2, ID is 5.33. And for VGS equal to minus 3 volts, it is 3 amperes. For minus 4, it is 1.33. For minus 5, it is 0.33. For VGS equal to minus 6, it is 0. Now let us sketch. This is VGS versus ID. For VGS equal to 0, it is 12. For VGS equal to minus 1, 8.33 something. 8.33. For VGS equal to minus 2, it is 5.33. And for VGS equal to minus 4, it is 1.33. For VGS equal to minus 1.3. So sketching all these points, you get the characteristics like this. Let us do one more problem. It's a simple problem. The problems you get on this JFET is the simple formula substitution. Most of the time you need to use only this formula. So at a Q point of JFET, ID is 3.5 milliamperes and VGS is given as minus 3 volts. Determine IDSS if pinch off voltage VP is minus 6 volts. Now let us see Shockley equation or square law equation. ID is equal to IDSS into 1 minus VGS by VP whole square. Now substituting all the values, ID is 3.5 milli, 10 raised to minus 3, IDSS we have to find. 1 minus VGS is minus 3 by minus 6, it is 1 by 2. Simplifying this one, solving this one, we get IDSS is 14 milliamperes.